Okay, we have to talk about rational expressions, and we'll start with simplifying them. So when you simplify them, I'll remind you what happens with simple fractions. You would simply write this as 6 over 3 times 6, looking for common factors. And I notice I have the 6 common to both, okay? Notice the 6 is a factor. 3 times 6 makes the 3 a factor, the 6 is a factor, and it's important that we remember to cancel factors. Okay? We want to remember that what you cannot do is when you have x plus 6 all over 6. Those 6's don't cancel because the 6 on the top is a term. Okay? It's the x plus 6 together grouped by the fraction bar. X plus 6 as a group is a factor. So it would be cancelable if it was common to both the top and bottom. So let's look what happens when we do have that. So for example, this is a rational expression with polynomials on both the top and the bottom, and I don't see any factors at all, right? So first thing I'm going to do then is factor them. And now that I've factored them, I can look at this and say, okay, now I have factors. You know, this first group in a parentheses is a factor. It's separated by multiplication. So I have my factors, so I can cancel now the common factor on the top with the common factor on the bottom. And of course then that leaves your answer, x minus 3 over x minus 5. So everybody thinks we're good to go, except there's one thing we really need to talk about that's very important in this chapter, and that's going to be what I call lost domains. And it's this idea that if you looked at the original function and compared it to your simplified, we want these two expressions, whether it's in factored form for the original or if it's in this form for the original, but these two forms have to be equivalent, right? We're trying to put an equal sign beside them. We're trying to write a simpler but equivalent form. And I'm going to posit that those two things are not equivalent at this time because we've missed the domain exclusions. So looking at the original, the original domain was all real numbers, x cannot equal 5, and x cannot equal 1. Because remember, the rule is always for domains that denominators, which will be the important rule for this chapter, cannot equal 0. Okay, but when I look at the domain of my simplified expression that I wished were the same, it's all real numbers as long as x doesn't equal 5. So you see where we have indeed lost this information. So there's my lost domain, and I have to go over here and add it in to this other domain. So I would say, final answer, how could you say this? You don't need to put the domain that didn't get lost, doesn't need to be repeated. So I would say x minus 3 over x minus 5 is equal to the original as long as x does not equal 1. Make sure you're including the lost domain in your original answer. That's an equivalent expression. Correct, I have not listed the whole domain for it, but that's another question. I could do that and talk about the 5. Just want to bring up one thing about remembering your opposites. We've spent some time talking about what is the opposite of this and that. What if I had something like x minus 3 is being divided by 3 minus x? And you look at that and say, gosh darn, those are the same. But no, they're not. They're actually opposites. So let me show that for you this one time, and then we're going to take some shortcuts. This is x minus 3 over the opposite of x minus 3. So I factored out the negative and maybe rearranged it a little bit. But now when I go ahead and cancel out common factors, what am I left with? Negative 1. Okay? So whenever you want, if you ever see opposites as factors, it's nice to be able to cross them out and just put a negative 1. Okay, so just a reminder of a shortcut you can take. So now we want to have more than one rational expression, and what can we do with them? And we'll start with multiplying and dividing when you have more than one rational expression. So let's, we've talked about monomials before. I'll give you one real quick to try. So here's one you can try, pause it if you want, but I will make the point, and I've tried to make this before, when you multiply fractions, top times top and bottom times bottom, yes. But it's better to cancel first and then worry about that. Otherwise you end up having to reduce after you multiply. So I'm going to go ahead and cancel everything I can right now. So when I look at this, I see a 4 and the 12 can come out and leave 3, because I'm going to take a 4 out of the 8 and leave 2. I'm going to take a 7 out of the 21 and leave 3. I'm going to take a 7 out of 14 and leave 2. Oh, that allows me to then go and cancel this 2 with that 2, cancel this 3 with that 3. Okay, but then I want to look at the letters. I'm going to cancel c squared, those two c's, leave c1 up here. This d to the 1 cancels out the d squared, and I have d1 up here. A to the 1 on the bottom takes away that one, and b in the bottom takes that all away. So hopefully you're neat enough to look and see what's left, because I've done a lot of canceling out. I've got a C, D, A is left, and I believe everything on the bottom was canceled out. So we want to multiply these two rational expressions. If this is really simple for you, you've been doing this for years, you can go ahead and skip. Otherwise I'm going to go ahead and work it out. I'm looking for common factors. Of course I don't see anything, so I will need to make sure I'm in, I factor some of these that can be factored. So let me rewrite this as a k minus 3 over k plus 1 is already as reduced as it can be. But 1 minus k squared is 1 minus k and a 1 plus k. Sorry for my two different kinds of k's. I'll try to keep them all the same. K minus 3 and k minus 1. Okay. So I've done all my factoring, and now I'm looking for common factors. I see the k minus 3's will cancel. But then I'm looking, I do have the 1 minus k and the k minus 1. So let me go ahead and cross those out and make sure I remember I have a minus 1 left over. Okay, so then it's just a matter of writing the answer of everything that's left, and don't forget if you have any, what we call them, lost domains. So I've got 1 plus k over k plus 1. Whoops, I obviously forgot to cancel those out. So what's left, gosh, the only thing left is my negative 1. So there's my negative 1, but I have to remember k cannot equal, according to my original, negative 1 plus 1 or 3. So here is my equivalent expression with its lost domains. I probably should have included a lost domain in the last one too. So A used to be in the bottom, B used to be in the bottom, C was in the bottom, and D was in the bottom. So this one is all true. A does not equal 0, B does not equal 0, C does not equal 0, and D does not equal 0. It's interesting that B is not even in the final expression, but it's still true that B cannot equal 0. Okay? So together would be the right answer. Okay, and I want to remind you that dividing is nothing more than timesing by the reciprocal. So I'm going to put a problem up, and I want you to try it. Okay, so there's a problem for you to try. Don't forget greatest common factors when you're doing your factoring. And I'm going to give you the answer. If you get that answer, you can skip the explanation. Okay, I've got the answer key here, so you can see what the answer is, but I do have to spend some time and figure out what the lost domain is, because those weren't in my answer key. So let me go through and work out this problem. I will say, some of the things that we forget when we're dividing is you can never divide by 0, right? And for this question to be divided by 0 is when d plus 3 is 0, because 0 over anything is still 0. So we know right away, I don't know if it's going to be lost yet, but we know d cannot equal a negative 3. We'll see if it's lost or not. Okay, so let's start factoring. 2 comes out, d plus 3 is left. On the bottom, d plus 2 and d minus 1. And then I'm going to switch these up. So the d plus 3 will go on the bottom, and I'm going to factor this one and put it on the top. So d plus 1, d plus 2. All right, now I get to take a look at this and see what's going to cancel. D plus 2 and d plus 2, d plus 3 and d plus 3. Okay, so that is indeed a lost domain, and what I'm left with is exactly what was expected, 2 d plus 1 over d minus 1. With the lost domains, d cannot equal -2 and d cannot equal -3. Both of those were lost. There you have it. Last thing we want to talk about is what do you do when you have a complex fraction. You never ever want to have more than one fraction bar in an answer. Okay, so if you get more than one fraction bar, you've got to simplify it. And the way to do that is to have your main fraction bar become a division, so you can turn that division into times reciprocal. Okay, so let's try one and work it through. Okay, so I think I can identify this one as the main division bar, so that one's going to become my division symbol. So I can write this as x squared, 9x squared minus 4y squared, divided by the x cubed over 2y minus 3x. And of course now I'm going to call that division right here as times reciprocal. So the first one, as you remember, always stays the same, but it is the times the reciprocal now. So change reciprocal of the second number, or the second rational expression. So now I have this that I can factor. Let me go ahead and cancel out what I can right now. So that cancels entirely and leaves a 1, and that cancels out that exponent and leaves a 1 exponent. So now I'm looking at 1 over, that looks like a difference of squares, 3x plus 2y and 3x minus 2y, okay, times 2y minus 3x all over x. So indeed I have some common factors, because remember this is grouped, close, but they differ by a negative sign. So this cancels, let me put a minus 1 here. Okay, so that gives me an answer now. I've got -1 over x, 3x plus 2y. But I have some lost domains, make sure I include them. Oh, with x's and y's, that idea of domain does get a little peculiar. But we better make sure that x is never equal to, what is that? Is that equal to 2y divided by 3, 2y over 3. Okay, I just want to make sure we're thinking about lost domains, even if in this case where there's x's and y's, it's not a function, so we wouldn't normally be talking about domains.